Bismillahirrahmanirrahim. Here we are speaking about the factoring of polynomials. The previous part we spoke about the factoring by taking out the greatest common factor. In the second part we spoke about how to factor trinomial if the leading coefficient is equal to 1 or if the leading coefficient is not equal to 1. In this part, we are going to speak about the special factoring. There are special types of factoring with that. It will be very easy if you know the type of the given polynomial. The first one is factoring of the difference of two perfect square. The difference between two perfect square. If I have a square minus b square, then this can be factored out as a plus b multiplied by a minus b. For example, if I have x square minus 9, this is difference between two squares. The first one is x to power 2. The second one is 3 to power 2. So the difference between two squares can be factored out as x minus 3 multiplied by x plus 3. One of them is positive and the other one is negative. Another one, if I have 4x squared minus 25. This is also difference between two squares. The first one is 2x all to power 2. It can be written in this way. 4x squared is 2x all to power 2 minus 5 to power 2, which can be written as 2x minus 5 multiplied by 2x plus 5. Or I can reverse 2x plus 5 multiplied by 2x minus 5. So if we have a difference between two squares, it is very easy to factor. Let's say, for example, if I have 16a squared minus 25b squared. This is equal to 4a all to power 2 minus 5b all to power 2. That is difference between two squares that can be written as 4a plus 5b multiplied by 4a minus 5b. So this is the first special factoring. If we have difference between two perfect squares, then we can write it as a plus b and a minus b. The second one, if we have perfect square trinomial, which is of this form, a square plus 2ab plus b square, we call this is perfect square. That can be written as a plus b all to power 2. Or a square minus 2ab plus b square equal to a minus b all to power 2. So the left-hand side we call it perfect square trinomial. That can be written as a bracket a plus b to power 2 or a minus b to power 2, depending on the sign of the middle term. If it is plus, I will have plus. If it is minus, I will have a minus b. For example, let's factor out or factor each perfect square trinomial. It's given that this is perfect square. But if it is not given, how do we know that this is perfect? To check whether it is perfect or not, I will take the x square. The square root of x squared is equal to x. 25, if we take the square root, I will have 5. Now from the formula I have, in the middle term there is 2. So if I multiply this by 2, 2 times x times 5 equal to 10x. Now 10x, this is the middle term. So this is perfect square. If it is perfect square, then it is very easy to be factored as bracket to power 2. So this is equal to something to power 2. What is inside this bracket? Square root of x will give me x. Square root of 25 is equal to 5, and the middle sign is a plus, so it is a plus. X plus 5 all to power 2. For the next one, 44. If we take the square root of y square, I will get y. Square root of 9 is equal to 3. This is y. If we multiply it by 2, because I have 2 there. So 2 multiplied by y by 3 equal to 6y. And this is the middle term, this 6y. So this is perfect square. And if it is perfect square, then we can write it as, this is question number 44, is equal to bracket 2 power 2. Y square will give me y, 9 will give me 3, and the middle sign is positive, so I will have plus. So it is y plus 3 all to power 2. Another example. But we have this one, 4x squared plus 12x plus 9. Now, if we take the square root of the first term, will give me 2x. Square root of 9 is equal to 3. Multiplied by another 2. This 2 from the formula. It is this one. This is 2. We have 2. So if you multiply by 2, I will have 2 times 2 is equal to 4 times 3 equal to 12x. 12x is the middle term. So this is perfect square. So this trinomial can be written as bracket 2 power 2. What is inside the bracket is, or are these terms? Square root of 4x squared, that is 2x. And square root of 9 is equal to 3. And the middle sign is a plus. So it is 2x plus 3 all to power 2. For number 48, also this is perfect square. We can check this one. Square root of 25 is equal to 5y. Square root of 6 or 16 equal to 4. Multiplied by 2 from the formula, I will have 2 times 4 is 8 times 5 equal to 40y, which is the middle term. So this can be written as bracket 2 power 2. The first one is 5y. Equal to 16 equal to 4. And the middle sign is a plus. So it is 5y plus 4 all to power 2. This is how to factor a perfect square trinomial. Now, another type of the special factoring is the factors of the sum or difference of two perfect cubes. If I have a cube plus b cube, or a to the power 3 plus b to the power 3, the factor can be written as a plus b, keeping the sign of the between the two cubes in the first bracket, then it is a square minus ab plus b square. If it is a to the power 3 minus or difference between two cubes, I will have a minus b, the negative, keep the negative or minus in the first one, multiplied by a square plus ab plus b square. This is how to factor sum or difference of two perfect squares. For example, I have this is exercise number 51, which is x to the power 3 minus a to the power 3. This is x to the power 3 minus 8 is 2 to the power 3. So I have difference of 2 cubed. This is the second one. That can be written as a minus b, which is x minus 2, multiplied by x square plus a times b, which is this is a, this is b, this is x and 2. 2x plus b square, that is 2 to the power 2, which is equal to 4. So this is how to factor x cubed minus 8, which is 2 to the power 3. For the 52, I have b to the power 3 plus 64. b to the power 3 plus 64 is 4 to power 3. So it is sum of two perfect cubes. So if we need to factor it, it will be b plus 4, the first bracket, multiplied by, till now we are in the second one, a cube plus b to power 3 or b cube, multiplied by b square plus 4 times b, which is, or this should be, yes, this is minus, not plus, it's minus 4 b plus b square. So this is the idea of factoring two cubes or sum of two cubes or difference between two perfect cubes. Number 57, I have x minus 2 over to the power 3 minus 1. This again will be the first one. Now this is a and this is b. The whole bracket is a and 1 is b or b to the power 3. Because 1 to the power 3 is equal to 1. So we'll have to factor this. The first one, which is x minus 2 minus 1, multiplied by second bracket, which is x minus 2 to power 2, which is a square, plus a times b. A is equal to, or b equal to 1 times x minus 2, plus 1 to power 2. This can be simplified more to be x minus 2 minus 1 is equal to minus 3, multiplied by, I can keep that one as it is, x minus 2 to power 2. We can open this bracket, plus x minus 2, that will be x minus 2 plus 1 is minus 1. That is x squared minus 2 to power 2 plus x minus 1. If we need to simplify it more, I can write it as x minus 3 multiplied by x minus 2 all to power 2 can be written as x squared minus 4 x plus 4 plus x minus 1. And what we did, we just expand this part. It is x squared, or using the identity a squared minus 2ab plus b squared, which can be simplified more to be x minus 3 multiplied by x squared minus 4 plus x is minus 3x, and plus 4 minus 1 this is equal to plus 3. So this is the factor of x minus 2 to the power 3 minus 1. For the number 58, we can do the same thing. I have x or y plus 3 to power 3 plus 8. This is 8 is 2 to power 3. So we can write it as y plus 3 plus 2 multiplied by the first one square minus a times b, which is 2 multiplied by y plus 3 plus the second one square. This can be simplified to be y plus 5, 3 plus 2 is equal to 5. Now the second bracket, so we can simplify that one to be y square plus 6y plus 9 minus 2y, and 2 times 3 equal to minus 6 plus 4, which is equal to y plus 5 multiplied by y square, 6y minus 2y is equal to plus 4y, and 9 minus 6 plus 4, 30 minus 6, that will be minus 7. So this is the factor of the polynomial, or the sum of the two cubes in the question number 58. So what we did was just we applied the special factoring to factor out these kind of polynomials or binomials or trinomials.